Hello, everyone. Thanks for joining, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is Discover the Power of AI with Oracle Data Science and AI Quick Actions, which will cover the foundations of AI and data science, OCI data science capabilities, and we'll have some demonstrations. This session is being recorded, and you'll be able to find the recording on Cloud Customer Connect. You can also find the recordings and content of our previous sessions there as well. I'd like to introduce Alan and Wendy as the main presenters, and with that, I will hand it over to Alan to get us started.
Fantastic. Thank you, Olivia. And it's a real pleasure to be here today. I'm Alan. I'm a principal member of technical staff here at the Data Science Service. So we work on all things sort of AI and data science and getting enterprises to leverage as much of Oracle Cloud and data science as they can. My co-presenter today is Wendy. She is the senior product manager here for the team and helps set our roadmap and prioritize, what's most important to us and our customers and all of you guys. So we're excited to be able to talk today about what we're doing and what we have to show you. So today's talk, Day One and Beyond, is about AI, OCI data science, and AI quick actions. So we're going to go through a few. I'll say, to put it in layman's terms, the beginning half is going to be more data science-y focused, and the second half will be more dedicated to Gen AI and what we're doing in that space. So I'll be taking that first half and talking to you about a few things and showing you a live demo of some of the tools that we have. So let's get started. So this is sort of what I went over, but I'm going to start just talking about the foundations of AI and data science and what capabilities we have. So to explain broadly, AI infrastructure that Oracle provides is massive. We have huge compute clusters, all sorts of regions and realms, public and private, CPU, GPU, and all different types of architectures. And there's an AI infrastructure team that's dedicated to, plugging in all these machines, making them work super well, having some of the highest speed networking available of any cloud. And we basically get to sit on top of that and leverage that. On top of AI infrastructure, we like to talk about the data layer. This is data lakes, object storage, of course, the Oracle database. And this is really Oracle's bread and butter. What really sets us apart, besides that AI infrastructure, is the quality of our data management ability. I'm sure that's no surprise. So we get to leverage this infrastructure and this data, and our job in the services and maybe the platform space is to leverage this effectively to make reusable tools for all of you guys to solve business problems. So within the platforms, again, we're going to leverage the data, the AI infrastructure. We have several different machine learning services, as we call them. So OCI data science is what we're going to talk about today. This is a set of tools for building, cataloging, deploying models, managing model lifecycle for both regular AI, Gen AI, large and small models alike. We'll spend a lot of time talking about that today, so I'll leave it there for now. But just so you know, there are other types of machine learning services. There's ML in Oracle Database, or OML. This focuses on machine learning models that are actually applied as SQL statements mapping on top of a database. So they can be run super quick, and it's a really smart team. And then MySQL HeatWave is another way of doing a sort of managed Spark service over your data. And AutoML is one of our internal proprietary libraries for doing machine learning. On top of that, we have many of these AI services that have been built using our platforms. So, for example, our speech service, or our document understanding service, or our generative AI service. These are all built using tools from OCI data science. Our model management lifecycle, our model deployments, our jobs resources. So the message here is that we're eating our own dog food, as our EVP says, but we're trying to use our own tools all the way through the stack so that you guys can slot in and use these platform tools just the same way our services do, and build whatever services you need. If they're not language or vision, maybe they're forecasting or something else. So then, of course, this is the AI world we're living in. And on top of that, we have all the business and industry applications, EPM, Fusion, Cerner, NetSuite, and all these great applications. So that's to give us a little context, a little grounding of where we're going. OCI data science is the focus, and let's dig in. So within OCI data science, again, we're sort of expanding that plot we just saw. We have data management and infrastructure down here, and we're in the platforms layer. We basically break it down into three main stages. We have the development and experiment phase. So this is when you don't know what you want. You don't have a production model yet. You don't know what tools you're necessarily going to use, but you need sort of the kitchen sink to get started. Play around with your data, get messy, see what's happening, and just get the first sort of view of your data. So for that, we offer notebook sessions, local and OCI code editors. We have all sorts of tools to help with that development process. And basically the idea there is that you can just get started in the cloud on an arbitrarily large compute shape with a pre-configured environment. So that's the base maybe. And within that, you need some stuff to do and ways to manage the various resources you create and leverage. So model catalog is one such resource, feature store, content environments. As you can imagine, the model catalog is basically a database or a storage facility for cataloging your models. So maybe you're experimenting and you have 5 or 6 different models that you want to try out. You can push them all to the model catalog and deploy and do comparisons and tests and all of that. Feature store, likewise, if you have a particular feature in your data set that might be reusable, say weather data, could be used across many different databases. Content environments, this is one of our huge advantages. We're partnered directly with Anaconda in order to build really specialized content environments to be able to run in your environment. So with the click of a button, you can basically install pre-configured content environment that has the latest and greatest packages that just lets you get started. Because as Python developers, we've all spent way too much time with environment resolution. So we have these sort of out of the box ready to go. So these are the base resources. And then on top of that, we offer ways of using these resources together. So jobs is our sort of headless notebook, we call it, or, everybody knows what a jobs resource is, but our jobs resource can be integrated with the model catalog. It natively can pull in content environments. They can be triggered from the notebook session. So it's fully integrated into this environment. Pipelines are a series of jobs that can have conditions and directed acyclic graphs so that you can make sure that your jobs are being triggered in the order you want. Model deployments are jobs, but they basically are running the whole time and they have an HTTP endpoint. So it allows you to take whatever model you have and make it with, again, one click of a button, make it an endpoint that you can ping from anywhere and start getting predictions. Model monitoring is exactly as it sounds. It's a way to track your model deployments and make sure that you have your drift dashboards and your analysis of what's going on there. Finally, LLMs. We have a lot around LLMs, specific dedicated extensions. I'll leave this for Wendy to sort of cover in the second half, but there's a lot of exciting stuff there. So first, we're going to go through this development and experimentation. And this is what the notebook session really looks like. You start with the option to start several different services, whether it's a Python script or the environment explorer we were talking about, or just a shell script. You can get started in a large CPU, GPU shape, directly running on the cloud, right next to all your data. So reading and writing data is extremely quick. It integrates with resource principal, instance principal, or however you want to talk to your resources. So it's basically a native way to run these, to get started working directly in the cloud. Next, we want to talk about data access and how to connect with your data. So sort of hinted at this, but within that notebook session, you can really talk to anyone, anywhere, or close it off entirely if you don't want to have public internet access, or you don't want to be able to talk to some specific websites. So that's all configurable within your VNIC, your subnet, which can be attached to your notebook session. In general, though, of course, we support reading from all areas inside OCI and outside OCI, and we have several built-in extensions that work directly on tools like Apache Spark through our OCI Dataflow offering. Next, when you have your data, we have our library that we call accelerated data science. This is really the API interface for the data science service. Of course, we have our sort of Swift standard APIs, but this is a way of making it more Python friendly, particularly Python data science. So it's integrated directly with all sorts of popular frameworks like Pandas and NumPy and all these things to let you directly manipulate your data, easy plotting, easy ways of interacting with all the OCI resources. For example, you can do ADS.pipeline to create your own data science pipeline. We'll talk about this a little more in the demo. Now we want to talk a little bit about managing and sharing. So projects is the largest resource bucket in data science, and it's basically a folder. It's a folder where you can put in all the resources associated with a project. So if you have a data science notebook session for predicting revenue, and you have several models and model deployments attached to it, and the revenue model team needs to talk to the database team, well, as long as all of the assets are kept within that project, you can share that project directly with the database engineer you're working with without giving them access to every single thing in your repository or everything you're working on. So projects are an important layer of abstraction that lets us put jobs and model deployments and notebook sessions into the appropriate buckets. Aside from jobs, content environments, as we spoke about, these are just pre-built ways of using some of the greatest libraries on Python, and many proprietary Oracle libraries are distributed exclusively through content environments. So, for example, PyGX, which is Oracle's graph analytics library. We have versions of Oracle AutoMLX that are distributed only through data science. And so it's really a great way to dive into your data and leverage the latest and greatest. Otherwise, we have the model catalog lifecycle management that I spoke of earlier. We have model version sets and all sorts of taxonomy so that you can push a model, grab the latest model, update your model catalog, and train. It's exactly what you'd expect and want from a sophisticated model catalog. Finally, we're going to talk a little bit about operating at scale, ML ops. This is all about the way that you can leverage the platform to scale in all sorts of different ways. Obviously, you can attach arbitrarily large compute shapes. So, think hundreds of cores. You can attach GPU shapes, including, the 8-core A100 GPUs. But you can also do a certain amount of distributed training by leveraging multiple jobs or multiple notebooks together and having them communicate. So we really do allow arbitrarily large compute shapes, compute clusters in order to run these jobs and deployments. ML pipelines is another feature we discussed earlier, but again, it's a directed acyclic graph. So one step can trigger optionally multiple steps, and upon success and failure, they can trigger the next round of steps. Very useful, and we use it a lot for managing our own pipelines, our own deployments, and all that. Model deployment is an excellent resource, sort of self-explanatory based on what we've been talking about, but one of the great features I'll highlight is auto-scaling. It works super well. You can start pinging this server and it'll go from one core compute, which is, an eighth of a laptop, and scale itself all the way up to hundreds of cores and be able to manage super sophisticated workloads. So it's really a great tool for, any way that you want to do inference on your model. Of course, we have lots of interesting integrations with the best of the open source frameworks for managing LLMs, which Wendy will talk about more in the second half, but there's a teaser for you there. ML monitoring, this last one I really want to touch on here, is basically exactly as it sounds, a library collection of tools and metrics you might need in order to create a drift dashboard or evaluate a model in development. ML Insights library is part of our tooling for that. Finally, we're going to get into what the demo is about. The demo is on AI operators. These are low-code tools that we build to directly solve a business use case. So today we're going to go over forecasting, but we have the the same type of implementation for many different types of use cases, including anomaly detection, event risk detection, PII, recommendation engines, and many more. So this is definitely an exciting space, and I'm excited to jump into this. So the AI forecasting operator is basically a way for us to pass a low-code YAML file um, into ADS and have ADS produce, in this case, a forecast. And the forecast includes not just the actual values in an Excel table of the next quarter's revenue or whatever it is, but also a report explaining what happened, metrics on it, explanations of how the forecast is made, parameters for reproducing the model. So it's a very scientific, reproducible forecast. And we think that's what makes a great enterprise forecast. So to start, I'll do a very simple example. I've loaded this data set locally, so we don't have to go over the internet or object storage, but this can be any format, and it can come from anywhere: object storage, database, S3, open internet, HTTP. So we have a lot of optionality here for where we load the data, but in this case, I loaded it locally for this demo. We can load the historical data just to see what data set is. So in this case, this is a popular open source forecasting library. It's the temperatures at Yosemite every 5 minutes. And the goal is to predict the next few hours of temperature in 5-minute intervals. So here, hour and temperature. In this case, we can see that the date time column is DS, and the target column that we want to predict is Y. We can make our selection of various different models. In this case, I'll use Profit, but we could be using any of these models, including AutoMLX, which is Oracle's proprietary modeling framework, again, distributed only here and in HeatWave. So why don't we predict the next 1 hour in 5-minute increments? And in this case, we don't need to check, but many times date time can be misformatted, so we can preview and make sure that this is the correct interpretation. So if we save this right now, we'll create a file over here called forecast.yaml. And if we go in there, this just created exactly what we told it to. And this is the YAML file that we can pass to a job or a deployment or run locally in order to trigger this forecast. Now, if we run this forecast locally with the Run Local button, you'll see the forecast gets triggered. It sees that there's already results folders 0 through 3, so it creates a results for directory. It loads the data. It builds a bunch of different models, hyperparameter tunes and trains, looks at plots and metrics, and then finally generates this results folder. As a preview, it gives you basically the basics of the plots here in the browser. If we look at the report, click into this folder, we can see that it generates a report as well as the forecast. If we scroll down to the forecast, sure enough, we have the forecasted values with a confidence interval range. So we can use that for our dashboards or whatever. We have metrics generated about the certainty of our training data fit, how confident we feel. So we have an R-squared of 0.9, which is pretty good. And finally, we get this report. So this report says it took 7 seconds to use a profit model. We had the other options, gives it a little description about profit. We can look at the preview of the beginning of the data, the end of the data, get some summary statistics on the data, various plots as we saw before. We can break down the forecast by trend even. So we can see that overall from April to July, the trend sort of dipped a couple of months, but was generally stagnant. Weekly, there's a pretty strong seasonality here of higher temperatures on a Wednesday. We can see the y-axis here isn't that large, but it said there's a slight pattern there. And within the day, there's a huge seasonality, as we can see swinging between 20 and -10. This is really the biggest component, as we'd expect. It's about coldest around 2 p.m. and then warms up into the night. We can go through and talk about more of the parameters and the seasonality, but this is a sort of basic forecast and a basic data set. what about the more complicated stuff? So we have a couple more minutes, so I'm just going to quickly go through a second example. In this case, we want to predict energy usage. So this is a meter that we have running, and we're getting readings every 1 hour. And the reading explains just how many kilowatts per hour are being used per household. And with this, to make it a little more interesting, we're going to attach weather data. So this weather data, again, for each meter, it grabs the local weather that was the visibility, wind bearing, temperature, dew point, pressure, all these different metrics. And we're going to pass both of these into the forecast and say, make me a multivariate forecast. And then try to predict energy usage. So again, we'll load this and make sure that all looks right. This is our new date time column. Energy here, normally you'd clean up that title, but it doesn't really matter. For simplicity, we'll stick with profit, and we'll do horizon of 5. Well, let's do 24. Let's predict 1 day. And I think that should be it. Oh, and if we had multiple meter IDs, we can use this meter ID column in this target category column, and we'll predict unique forecasts for each meter ID while leveraging the multivariate nature that each of these forecasts is interrelated. So don't need anything else from there. We'll again save this so we can check our forecast file. This is all you need to reproduce this forecast. You don't need the UI or the notebook. You can just pass this to a job, run it locally, etc. So we'll run this locally. Again, we could run this as a job, and what that would do is spin up a compute instance as a job resource, attach networking and block volume, pull in all this data, run the forecast, and then push the result into object storage so that we could retrieve it later. Now, if we look at the output here, we can see there's some plots, some stuff has been run. But basically, it was another 7 seconds to build this big model, produce all this stuff. So let's go look through and see what they did. So this is results 5 in this case. We can see it was created a couple seconds ago, and we have this report file. So within the report, oh, my mistake, took 3 seconds to run. It was hourly data from 2012 to 2014. So 18 months of hourly data, big data set. And we can see there was only 1 meter ID detected, took 3 seconds. That's 12,000 rows. So we get some summary statistics again. We get the overall forecast. We can see that there are definitely some anomalies in energy usage spikes that we can't predict. But for the most part, we're capturing a lot of this trend. And I think, again, what's most interesting is to break down the trend components and see that the model's roughly getting it right. So the overall trend, there's some pattern to it that roughly mocks, it's a little higher in the spring, it's lower in the summer, a little higher in the winter. That probably makes sense. A weekly seasonality, again, very small y-axis. It's mostly capturing that there's not much pattern here. And then there's the hour of the day seasonality that captures that between 3 and 6 a.m., there's really not very much energy usage, and at night it is at its peak. This area, additive regressors, this is all of the extra data and how much it contributes. So what we can see is that actually the time of day is much more predictive than all of those other variables combined. But those variables are much more predictive than the day of the week or anything like that. So this will be a combination of knowing the dew point, the temperature, the humidity, that's able to contribute up or down this many, basically kilowatt hours per household. We won't go through all of the other technical terminology we could or explanations, but as you can see, there's a lot of power to being able to use this forecast. It runs very quickly, and it can run locally or remotely. And this is an example of the forecasting one. But again, we have them for anomaly detection, recommendations, video review, all sorts of different stuff. So if you're interested in a low-code business solution, I would definitely recommend checking this out. We've got more documentation here that I can send along afterwards. Okay, I think that sort of wraps it up for my demo. I'll pass it over to Wendy, and she can get to, I think, the more exciting half, which is talking about generative AI and the ways we can help.
Okay, thank you, Alan. Hi, everyone. My name is Wendy Yip. I'm a senior product manager with OCI Data Science. So I'm going to talk about a feature that we have in OCI Data Science called AI Quick Actions for large language models. So AI Quick Actions is a feature that inside the data science service, it came out about a year ago. So we have seen a lot of customers who are interested in using large language models. You know, the generative AI space has attracted a lot of attention, become very popular in the last, I would say, couple years. So traditionally, people can use our platform, data science platform, to build and train their machine learning models. They can bring a container and then deploy the model, and run a large data science job to help them fine tune their machine learning model off of the data that they have. So our platform, lets you do all of that, and you can do that with large language models. But we recognize that there are a lot of people, a lot of companies, they have business use cases. They want to leverage the power of some of these large language models, but they might not necessarily have the expertise and to be able to build a container, bring a machine learning model, and then figure out all the things that you need to do to deploy it and then start using it in an application. So we created AI quick actions so that you can deploy, fine tune, and evaluate these generative AI models with just a few clicks. So this can really open up generative AI models to a wider audience, not just limited to data scientists and machine learning engineers. So AI Quick Actions is available in all OC1 regions. We are going to launch in Gov and the dedicated regions really soon. So to use AI Quick Actions, it's the same price. It's the same pricing model as data science service. So data science service only charges for computes and the storage costs for the underlying resource that you're using. We don't have any additional markup. It's actually the same as if you were to use OCI compute or OCI block storage. It's the same price. Okay. So when you first get to AI Quick Actions, what you see is a Model Explorer. Under Model Explorer, you will see a list of a list of kind of, I would say, popular foundation models that you can use for deployment or fine tuning right away. So some of these models are Meta's Llama 3 models, Falcon 5.3. If you have a model that you want to use, but you don't see in the Model Explorer, what you can do is bring your own model from either Hugging Face or OCI Object Storage. Hugging Face is probably the most popular online machine learning model repository. So if you see a model that you want to use, for example, maybe a model that is really good, that is trained and really good at, in Italian, you can, and you find in Hugging Face, you have this option to register a new model and download it from Hugging Face, and then you can bring it in and leverage our service managed container to deploy and fine tune the model. Okay, so why would you want to fine tune your model? So you might have you want to fine tune a foundation model so that with data sets that is specific to your particular business or particular area of your domain area. So that's more, it will provide responses that are more specific to what you're working in. So if you can fine tune foundation models in AI quick actions by going to the fine tune option. You can use your own data, and the data is uploaded from either your local machine or object storage. It doesn't leave your tenancy, so you can rest assured about data security. And also, once your model is fine-tuned, it will be saved in your model repository. You can also deploy a model and turn it into a data science model deployment. So that will give you an endpoint that you can use to make to generate new responses with new data. So once you have done the deployment with AI quick actions, we have like a playground where you can test out the model in real time. So you can see how, you can give it a prompt and see the output that it gives. And then you can also generate evaluation reports in AI quick actions. You can select a model that you have deployed, a data sets that you want to evaluate the models on. And then we have a few industry benchmarks that we have chosen, like Rouge score, Blue score. So when you go to evaluation, when we create the evaluation, it will generate a report based on these metrics. And the report is in an HTML format. You can use it to decide if the foundation model the performance is acceptable for your specific use case and criteria. So I have a demo for how you can bring in a model to use in AI quick actions, what it will look like. So I'm going to play that for you.
This is a demo of how to import a model from Hugging Face to OCI Data Science AI Quick Actions. First, you need to navigate to AI Quick Actions. When you get to AI Quick Actions, you'll see Model Explorer. You want to bring in a new model. You can click on the register a new model button. You can bring in any model from Hugging Face or OCI Object Storage to AI Quick Actions. But first, you have to go through the model registration process. So when you click on that button, you have the option to import a model from Hugging Face or bring in a model from object storage. Let's choose Hugging Face. Then you have two options: register service verified model or register any model. A service verified model is a list of models that the data science service has tested the configuration for. You can choose to use one of these, or you can choose to bring in any model that you want to use. So if you choose register any model, you would want to type in the name of the model found in Hugging Face. So for example, I have this model here. Let's say I want to bring this model into AI Quick Actions. I can copy the name, put it here. After the model is found, you can see some summary statistics of the model. Then you have the option to choose an inference container to work with this model. We support VLLM and TGI. If you bring in a model that is in GGUF format, you have another option for inference container. You'll get an option to use an inference container running Llama CPP. Okay. Let's go back to this model. I'm going to register it. I'm going to choose the inference container. And then I can choose which object storage location to store the model artifact. I can optionally choose to fine-tune this model after it has been registered. And then I can click register. So this process can take a little bit of time. After the model registration is complete, you see your model in My Models in Model Explorer. It'll have its own model card. You can click on it. You get some information about the model, and you can choose to deploy or fine-tune it. Certain models in Hugging Face, they are gated models. That means they require you to accept a user agreement before you can access them. So for example, the Meta's Llama models are like that. If you want to bring these models to be used in AI quick actions, you need to generate a token in your Hugging Face account and then log in through the Hugging Face CLI in the notebook session running AI quick actions in order to bring these models in. This is because we want to validate that you have accepted the user agreements and indeed have access to those models. So before you register these models, open up a new terminal and then log in to the Hugging Face CLI with your token. You can paste your token here and then press enter. If you fail to do that and try to bring a gated model, your model registration is going to fail. Now, let's say I want to deploy this model. I can click deploy. I can choose the compute shape I want to use for deployment. I can also optionally select the logging. This is recommended, so it will help you troubleshoot in case of any issues with the model deployments. And you can also choose what inference mode you want to use with the model, either the default completion endpoint or the chat completion. And then you can choose deployment. After the model has been deployed, so it's creating right now, you'll see a list of the deployments you have. I'm going to choose a model I have already deployed earlier. Okay. You can test the model in real time with this inferencing UI. Let's give it a prompt.
Okay, so that is a demo of AI quick actions. So just to summarize, this is a fully managed, our OCI Data Science, a fully managed platform that facilitates building, training, machine learning model. You can use Python and open source tools in our platform. We have a relatively new feature called AI Quick Actions that lets you deploy, fine tune, and evaluate foundations model in a very code-free, in a streamlined code-free environment. So this makes foundation models more accessible to a wider audience. If you have questions about the data science service, I have put the links of our documentation here, our GitHub repo. I would highly recommend going to a GitHub repo because it has a lot of examples of different use cases. It has examples like, for example, in AI Quick Actions, how do you do deployment? What are the configurations? There are a lot of really good tips in there. You can also check out our Oracle Data Science and AI blog. There's no section that is just like data science, but it has like it's really AI services and data science combined. But you can scroll through and see the different topics we have. We have blog posts on how to do like how do you do something? How do you create, like, for example, a chatbot, in using an open source model in data science. So go check that out. And then you can also reach out to me if you have any further questions. Okay, so now I'm going to turn it over to Olivia.
Thanks, Wendy. So yeah, this slide is just ways of learning more. We have live labs if you want to get more hands-on experience. There's Oracle Learning, YouTube, all of that. And then on the next slide, we also have some other programs that you can explore. So we have Day One and Beyond here. But if you want more one-on-one customized sessions, we do have our personal training and our live labs. So if you're interested in that, we do have our email down at the bottom. And then there's also Code Innovate. So it's a 5 half-day event where Oracle engineers help you co-develop some of your use cases. So that's another program that you can explore. And then lastly, this is just a list of some of the series that we offer as part of Day One and Beyond. So we have our core series, but we also have hands-on cloud native, security, analytics. Did you know all of that? So please feel free to explore those. And then our next session will be enhanced application speed and scalability with Oracle's Managed Bulky on March 18th at 10 a.m. Pacific. So we hope to see everyone then. All right. Thanks everyone for joining.